3.2, solving two-step equations. Again, the minimum is 1 through 19 odd. The more you can do, the better. If you find any that are kind of curious, a couple here that you might need a little refresher on, or that are new to you. These sort of verbal statements: the output of a function is 5 more than 2 times the input. We'll work on those. So that's a case where you might want to do all of those because they're probably less familiar to you. So better to practice those. And then again, the word problems. I've told you to do 19, 20, and 22. This one, I don't know. Sometimes they just get a little too sort of convoluted for me. So give those a shot. And again, check your answers. Even trying and not getting it, but then checking it will help your brain get better at this. Okay, so two-step equations. Again, this whole idea of this is where the PEMDAS, or sorry about you Canadians or Europeans, BEDMAS. Either way, we're doing order of operations backwards when we want to undo something. So notice here's division and here's addition. I'm actually going to undo the addition before I undo the division. And again, I'm just showing you quality problem solving steps. And, you know, again, I like to write this as 2 over, because you realize this is in the numerator, this is in the denominator. 2 divided by 2 is 1, so 1x equals 12. Again, subtraction before division, or addition before multiplication, undoing addition before undoing multiplication. So 5x equals 15, divide by 5, x equals 3. I'm going to add 7 first, and here's a z. I might just change it to an x, as I've said before, just to make things easier to see. And if I multiply by 3 over 1, I can see that 3 divided by 3 is 1, so x is 18. And I just like to put my 3 up here because, again, the 3 is in the numerator, and so is the 6. So we don't often write over 1, but I just think it helps us see what's in the numerator, what's in the denominator. It'll be helpful later. What's going on here? Well, I have a 7x minus a 4x. Those are like terms, so the first thing I should do is combine those. You can't add 4x to both sides because then you'll have x's on both sides. I don't know, it's confusing. Just combine like terms when you can. So then divide by 3, and x equals 7. Again, here's a case where I can combine like terms. 5d minus 9d is a negative 4d. Divide both sides by negative 4, and d is equal to positive 4. Here's some of those problems I was talking about. Oops, today is the 19th. Name, date, assignment. You don't have to put the title, but always this heading. The output, it's generally what we call y, is 3 less than 5 times the input, generally what we call x. So how do these words translate into math symbols? Output, y, is 3 less than, so I'm going to subtract 3 from 5 times the input. If you read it, I guess, literally in this order, the output is 3 less than the input. You could have seen it that way. Find the input when the output is 17. So I know the output is 17. Add 3. 5x equals 20. X equals 4. I did this ahead of time to allow just be more efficient in recording the videos. I ran out of a little space here, but notice how much space I am using. Use space. It's just is going to reduce your error and allow if you do make an error, a lot easier to find. Okay, we're going to try this one. Output is 4 less than 4 times the input. Oh, that's a lot like this one. I guess I just picked two that happen to be the same. The output is 4 less than 4 times the input. Find the input when the output is 3. And you guys can do the rest. This is a pretty classic linear verbal statement. You have a job and you get $8 per hour plus tips. You made $35, 13 was in tips. How many hours? Let's think about what this part would say. That your income is $8 per hour. You're going to get $8 every time you work 1 hour. And then plus, let's say, your tips. Essentially, I should define variables. That's always a good habit. H equals the number of hours you work, and T equals your dollars in tips, right? So you made $35. Your tips were 13. How many hours did you work? There's different ways to go about it, and again, lots of times people just do this in their head. Oh, well, I took 35, I subtracted 13 and got 22. Is that right? Yeah. And then I divided by 8, and that told me how many hours. Well, if you even did that, think about writing that in your head or writing that down. How did you do it? I did 35 minus 13. And then you might have said, well, what's left is the $8 per the hour that I worked. And then you could sort of turn that around into kind of a y equals mx plus b form. So good to think about your process. All right, that should go relatively quickly.